Alright, so now we're up to the second derivative, acceleration, and if I just take this first bit here, u dash would be 2r cos theta times v, which is just that square root of 5 minus 4 cos theta, and then be going plus, now find the derivative of this section, which you can see then minus a half will come down to the front, so I'm going to go minus, I'm going to get a half, minus a half, I've got 5 minus 4 cos theta to the negative 3 on 2, and then go inside and times by, so negative 4 will go to positive 4 sine theta, and then times by our 2r, so our u sine theta. I think I've got it all there. Alright, so what does that become? It becomes 2r cos theta on the square root of 5 minus 4 cos theta minus, alright, so we've got a half, but the 2 cancels there. So we've got a 4r sine squared theta on top. And on the bottom we've got the 5 minus 4 cos theta, but it's to the power of 3 on 2. Alright, if we want that common denominator, we'd have to times this first term by a root 5 minus, because that's already a half, and we want 1.5, so I times both top and bottom by 5 minus 4 cos theta. So if I do that, I've got 2r cos theta, and I'm timesing by 5 minus 4 cos theta. Minus 4r, I'm going to put it all in terms of coses, so sine squared is 1 minus cos squared theta, all on that 5 minus 4 cos theta to the power of 3 on 2. Alright, so if I just look at the top of that and expand that all out, I'll do it in a different colour because I'm running out of room, so you can see, so you've got 10r here cos theta, and then minus 8r cos squared theta, minus 4r, and then plus 4r cos squared theta. So you can see if I put that all together, I'm going to get minus 4r cos squared theta plus 10r cos theta minus 4r. And if we factorise by minus 2r, we would get 2 cos squared theta minus 5 cos theta plus 2 all over, oh, run out of room, that bracket at the bottom. Okay, now if we want the maximum speed, that would be where the acceleration equals 0, and this is the acceleration. So where does the acceleration equal 0? Well, we'll just make the top equal 0. If I let m equal cos theta, I've got 2m squared minus 5m plus 2 has to equal 0 to make that acceleration equal 0, which will give us the maximum speed. So if I factorise that, I'm looking for where cos theta equals a half and 2. Now we know cos theta can't equal 2 because cos theta goes between negative 1 and 1. That's its amplitude. So I'm looking really for where cos theta equals a half. And we know that is at 60 degrees, so pi on 3. And in the fourth quadrant, cos is positive again, so 2 pi minus pi on 3, which is 5 pi on 3. So at both these times, we're looking at a maximum speed. So if I do right, I need this room. If I do a bit of a table, so hopefully you've got that written down somewhere. And I look at the angle for, so I'm looking at pi on 3 and I'm looking at 5 pi on 3. So I might look either side at that, at a 2 pi, at a pi on 2, let's say, maybe a pi on 6. And I'll look at my acceleration, which is my double derivative. So I'm going to pop that in, so cos pi on 6 first, and then I'm going to put that into the top, the double dash equation, into this equation basically. So see if you can put it in, you'll get a positive answer. I'm not working out the number, I'm just working out whether it's positive or negative. We know it's 0 for that one, we know it's negative, 0 for that one, and at 2 pi it's going to be positive. So what does that mean? So you can see in this case it's accelerating, and then it goes to 0, and then it's decelerating, and then it goes to 0, and then it's accelerating. So it's accelerating, then 0, accelerating and then 0 and then decelerating. So that part is going to be a max at pi on 3. Here it's decelerating, then 0, then accelerating. So it's going to be a minimum at 5 pi on 3. So the other thing to look at is dx to theta at pi on 3. Now dx to theta, which we've got up here, if I pop in pi on 3, I'm going to get, so pi on 3 is 60, sine 60 is root 3 on 2, and cos 60 is a half. So we're going to get 2r, root 3 on 2, and then the 5 minus, root 5 minus 4 times a half, so 2. So that's going to end up being a root 3 on a root 3, so we're just going to get r for that one. If I put in 5 pi on 3, I'm going to get minus 2r root 3 on 2, but it's negative, that's why I put the negative on the front. And then we're going to get a root 3 here, sorry. Which also gives us an r, but it's a negative r. So what we have there is that the maximum speed is occurring at that theta equals pi on 3 when dx to theta, so the change in x as theta changes with respect to theta, being r, and then the minimum speed is when our angle is 5 pi on 3, and that's when the change is negative r up here. So you can imagine from this picture here, if I just pull this picture down a bit, actually I'll make it a bit bigger, nope, there we go. So when this is a tangent, oops, so it's at 90 degrees here, this angle will be our when we're getting our maximum speed, which is pi on 3. So it's heading directly away from point A here. So it's pulling on it, so you can see that here this is going to be going up here. So it's directly towards A, whereas if it's at another point, it's not directly towards A, so we don't get that tangent. And if we have the tangent here, which is our angle, our other angle, so 5 pi on 3, this time it's heading directly towards A. So it's shortening this rope, so now we're going back down here. It's not pulling on it, it's letting it go. So maximum speed when theta equals pi on 3 and dx to theta is r. Minimum speed at theta equals 5 pi on 3 when dx to theta is negative r.